let's just repeat first the definition of logarithms, so our little numerical formula here. So b to the power x is equal to y is equivalent to saying that the logarithm in base b of y is equal to x. So remember, what a logarithm is asking is how many b's do we have to multiply together to get y. So let's just have a look at changing between these two ways of saying the same thing. And I've got a little colour scheme here which I'm sure is going to go astray, but let's try. So if we've got 10 to the power 3, so here our base is 10, our exponent is 3, that is equal to 1000. And that is equivalent to saying, therefore, that the logarithm in base 10 of 1000 is equal to 3. So really what we're asking is how many tens to get to 1000. And the answer is that 1000 is equal to 10 times 10 times 10, so that's 3 tens, so it's 10 to the power 3. So that's where this comes in. I'm just going to do a couple here. So another example, how about if we've got 3 to the power 4 is equal to 81. And that is equivalent to saying that the log in base 3 of 81 is equal to 4. So here, logarithm in base 3 of 81, how do we work that out? So that's the same as saying multiply how many 3's to get to 81. And the answer is that 81 is equal to 3 times 3 times 3 times 3, 9, 27, 81. That's 3 to the power 4. So that's where this 4 comes from. We have to multiply 3 by itself 4 times to get to 81. And one more. How about 5 to the power 3 is equal to 125. So that is equivalent to saying that the logarithm in base 5 of 125 is equal to 3. So again, we ask the question, multiply how many 5's to get to 125, and the answer is that 125 is equal to 5 times 5 times 5, or 5 to the power 3. So that's where this 3 comes from. We have to multiply 3 5's together to get to 125. Alright, so now let's use this to work out what the value of this blue number is, what the value of the exponent is. So I'm just going to do a couple of examples that way. So let's say that we want to know, here's an example, so we want the logarithm in base 3 of 27. And we want to know what that number is. So we know that that's equivalent to saying that we want to know, so 3 to the power something, so that's this same number here, is equal to 27. So we just ask that same question. So we multiply how many 3's to get to 27. And so 27 is equal to 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So that's 3 to the power 3. And so that's our answer. We have to multiply 3 3's to get to 27. So the logarithm, so the power here, 3 to the power 3 is equal to 27, and so the logarithm in base 3 of 27 is 3. Let's do another example the same. So if we've got, what we want to know is the logarithm in base 10 of 100,000. What is that equal to? That's equal to something. And so on the other side we can say that if 10 is the base, then we need to raise that 10 to some power, and then that will be equal to our 100,000. So how many tens to get to 100,000? And so we say 100,000 is equal to 10 times 10 times 10 times 10 times 10, or 10 to the power 5. 100,000, 10,000, 100,000. And so here our exponent is 5, so 10 to the power 5 is equal to 100,000, and therefore the logarithm in base 10 of 100,000 is 5. And so that's the general principle of how you convert between logarithms and powers.